Okay, so we have discussed about our computer. In these three basic components, we have discussed about, I think, the processor, the processing unit, right? Unit. We have discussed about the memory very, very briefly. We have also discussed about our input-output system, obviously very briefly. And then I think you talk about this one, right? The system bus yesterday. We think I think we know that in this system bus we have three basic components, right? One is the address bus, data bus, and control bus. And I have said that the size of the address bus, right? The size of the address bus, that means the width of the address bus, is by using this width of the address bus, we can easily find or easily can calculate the maximum size of the memory, right? So can you remember that relationship between the address bus and the memory, the maximum size of the memory? What is it?
Yes, sir.
What is it? What is the relationship between this address bus and the memory? What is the relationship?
Hello, sir. I'm Maniakas speaking. The relationship between the address bar and the input-output system is we need the ability is added bar for the input-output system. Like I have the 64-bit computer. Okay. In my system, for that system there is a specific memory in my location. I cannot use more or affiliate system around there, otherwise it won't take space. Like I have memory like 1 terabyte in my PC. In the address bus that controls the whole the dashboard that controls the whole I/O system. It will affiliate only 1 terabyte for 60-bit at that time. It also controls the I/O system. Otherwise, the whole memory will use on be.
All right, fine. Thank you, Mr. Akash. Yes, it is fine. It is fine that you are right that the size of the address bus, that is the width of the address bus, by using this width, we can easily find out that what is the total maximum size of our memory. If your address bus is 16-bit, then yes.
Sir, if the computer is at 16-bit, the memory is 2 to the power 16.
Yes, the maximum memory is 2 to the power. Maximum memory is 2 to the power 16, correct? So that means it is 64 kilo. If it is 32-bit, then it will be
32.
Yeah, that is 4 giga. And if you have 64-bit system address bus, then you have 1.8 terabit of memory. So that is the relationship. And I think I told you yesterday about this one, that why we do 2 to the power 16, 2 to the power 32, or 2 to the power 64? Because it is a binary system, and this binary system can have that many combinations. Because we know that each of the combination located of one of the location of the memory. Right? For example, 101010 is located or refers to one location of the memory. So each of the address is actually referred to one location of the memory. That's why we can have that amount of combination for that amount of memory. And it is general that the size of the address bus is equal to the size of the data bus most of the time. Right? Size of the address bus is equal to the size of the data bus most of the time. And if you think about the control bus, do you remember about the control bus? Our control bus is, if you look at the last point, the control bus, we have several controls in signal. We have several controlling signal. For example, our memory read, memory write, input output read write, interrupt request, interrupt acknowledgement, bus request, and bus grant. These are the special types of signal by which we can do different types of tasks. And these are the control signal for the control bus we can see here. All right, so this is the overall summary of this system bus, where we have address bus, data bus, and control bus. Fine?
Sir, actually,
Yeah.
sir, I have a question, sir.
Yeah, sure.
In the control bus system, sir, why always computer works on 0 and 1, sir? Why not other numbers, sir?
Because our computer is a binary system, that's why.
Sir, but in the last semester we have worked on some circuit, sir. In the circuit there is a point that both are dependent to each other. In that system, 0 is out and 1 is in, sir. But I have my personal question, sir. If there isn't there a system that in common, sir, 0 and 1?
I actually don't understand your question. Maybe you're asking that why our system is only 1 and 0, right?
Yes, sir.
What do you think what it should be instead of 1, 0?
Actually, sir, when we work on 0, the circuits is closed, sir, and when we work on 1, the circuit is open. But there, if anyone asks me, sir, that and the circuit is both open and can be closed in the situation.
No. Listen.
Okay, sir.
Why we have 1 and 0 and how we represent 1 and 0 in the circuit level is not on and off. It's like in this way. I think you know that we have a voltage, right? We have a voltage. So
Yes, sir.
when the voltage level is from 0 to more or less 2.5 volts, then we consider it as 0. When the voltage level is 2.5 until 5 volt, then we can consider it as 1. So there is no overlap. So it is not possible, can be overlap. All right, that is one thing. Whenever you store the data into the hard disk, our hard disk, so in that hard disk, we also have 1010, but that 1010 depends on the pole, North Pole and South Pole. So whenever you have a North Pole and South Pole, there is a current. Or whenever you have opposite pole, you don't have any current. So when there is a current, you have considered as 1. When there is no current, then we can consider as 0. So there is no possibility to overlap each other.
Okay, sir. Yes,
all right,
sir.
you understand?
Yes,
so
sir. Completely understand, sir.
There is a clear difference between 0 and 1. Okay, but there is several ways. If you are using CD or DVD, the 1 and 0 represent different way by a laser light. So when the laser light hits the CD surface, if it is come back, then it is 1. If it is cannot come back, it is 0. All right, so that's why we can define 1 and 0 in so many different parts. In the register, in different way, cache, main memory, our hard disk, CD, DVD, that's hard disk, tape. So many different way we can do that. All right, either it's a magnetic disk or maybe it's a transistor or it can be an optical disk. Okay, fine.
Yes, sir. Completely understand.
Thank you. One more thing. Just one thing. I need to switch off. Oh, wait. Fine. Okay. All right. So let us continue our discussion. So we know that about our three basic system. We need to know one more thing, which is the last topic. If you can see my last this one, the master and the slave. So whenever, just try to understand, whenever any data transmission starts, let's say you want to send the data from processor to input output, or input output to processor, or processor to memory. So you have to initiate that data transfer, right? So whenever you start a data transfer process, right, whoever initiates or whoever starts the process will be the master of that data transmission. And whoever receives the data, that means whoever is the target system, that will be the slave of the system. So why we call master and slave of any of all the data transmission system? Because master controls all the things, all the activity, all the permission and everything. All right, that's why we call it master. Slave just follow the instruction from the master device. All right. So most of the time, you can see the last line is written. Most of the time, the processor is always the master, and the other devices are slave. All right, fine. So just remember this one about the master and the slave, that most of the time, the processor is the master and the other device is slave. Why we call it master? Because master will control all the data transmission process. That's why we call them master. All right, let's go to the next slide. Let's start about our processor. Very, very elaborately about the processor. We know that the main objectives or main responsibility of the processor is to execute the instruction, right? Execute the instruction. So to execute the instruction, we have three basic steps. First step is the fetch the instruction. Second step is the decode the instruction, and the last one is execute the instruction. So what is the fetch instruction? Fetch instruction is whenever you try to execute any instruction, you have to get the instruction from the memory. You have to read it from the memory. You have to collect it from the memory. That is called a fetch. Fetch means get it, collect it, right? So that is the fetch. That is the fetch instruction. Next step, after fetching the instruction, you have to understand that what that instruction means to the microprocessor. For example, you write a code in C and you have an instruction. So whenever the microprocessor reads that instruction, which is written in C programming or any other language, it needs to understand, because microprocessor doesn't understand the C programming language or any other language, not even the assembly language. So whatever the instructions it get or fetch from the memory, the microprocessor must decode it. That means must interpret it or translate it into the machine language, which is 1010, right? That is called decoding. That is the second step. Third step, after decoding, then you can do the execute of the instruction. Most of the time, we do use our ALU, Arithmetic Logic Unit, for our logical and arithmetic task. And we have another part, we have register, we have control part of the microprocessor. We use them also for executing the instruction. Right, so this is the overall idea about this execution cycle. There is another name of this execution cycle, which is called fetch, decode, and execute cycle. You can see at the last line, fetch, decode, execute cycle. All right, so that is the name, or you can simply say it or call it as a execution cycle. Fine. So the first one is the fetch, second one is the decode, and third one is the execute instruction. Fine. This is and by the way, this is a cycle, because the moment you start your computer, this execution cycle starts from that point until you shut down your computer. All right. I cannot see the process right now because I have shown you several times about my computer task manager, right? You can see that hundreds of process, and it will run until you shut down your computer. So this is a cycle. This is the execution cycle. All right. The moment you start your computer until you shut down your computer. All right. That's what it's called cycle. So it's fetch, decode, and execute. Fetch, decode, and execute, and again and again and again. All right. So you can see that to do the fetching, look at the process. It's written here, and we are using all the address buses. All the system buses to do the fetching. Look, to do the fetching, you have to place the address of that specific memory location into the address bus. I told you before, address bus contains only the address of the memory location. So it press the address of that memory location wherever you can get or fetch the instruction. After that, you have to activate the read signal. If you remember about our control bus, this is a memory read operation, right? So your control signal should be memory read, right? This one, memory read. So in the control bus, you should have a memory read. In the address bus, you should have the address of that specific memory location. And then in the data bus, you can get that instruction. That's how we can do the fetching, right? And that is also a good example of our system bus, that how we can use them, right? Fine. So the decoding, as I said, decoding and execution is a similar thing we have just discussed. Let us continue with the next topic, which is the system clock. Do you remember whenever I show you my processor? Can you remember what was the clock cycle of my processor? No?
You mean a Pentium?
No. Pentium 4 is the model number. Okay, not about my one. How about your one? Some Hutch.
Yeah, 3.29.
3 point something, right? My one is 3.7 gigahertz. So 3.7 gigahertz is my clock speed. Not my clock speed, my processor clock speed. So 3.7 gigahertz means 3.7 10 to the power 9 task it can do in 1 second. Right? So that means this clock cycle or the system clock is actually the unit of the processor. Okay, look at the last sentence. With every tick or the cycle of the clock, the CPU is able to process one piece of data or execute one instruction. So if you have 3.7 gigahertz, which is your speed, that means you can do 3.7 10 to the power 9 task or data you can process in 1 second. Sometimes when some of the processor has some boost, I don't know, you can see it in your task manager that although your processor is, for example, my case, my processor is 3.7 gigahertz, right? But sometimes when the processor is so busy, right, at that time it exceeds 3.7, sometimes it's more than 4 because it has some booster. Not always, whenever it is busy. That's a different story. But what actually I'm saying that the system clock is in each cycle, you can do one task or you can process one data by the processor. And the unit of this is hertz. Okay, fine. The clock frequency is measured in the number of cycle per second. And this number is referred as hertz. Fine. Do you understand about the clock cycle? That means this is the one cycle. In one cycle, you can do one task. So the more you have, the more capability you have of your processor, the more faster you can get response, the more work you can do by your processor. Okay? You can check your one. I will give you one home task very soon. It will be individual task to find out the processor of your mobile phone you are using. I will give you very soon. Your task will be related to your processor of your mobile phone. You need to find out what is the processor of your mobile phone, what are the name, model number, speed, of course the clock speed, the RAM, not the RAM, the number of the register, and which type it is, RISC or CISC or ARM or ARP, all about this. Okay, I will give you an home assignment and it will be individual assignment, not group work. Okay, very soon. So if you know these topics like clock cycle, your execution cycle and all this, it will be helpful for you to find out those information. Fine, any questions so far? We have to complete this syllabus, not syllabus, this chapter soon. Otherwise, we don't have that much time. We have only one more week, or maybe 10 days before your first term exam. Any question? Anyone? No? Sure. Sure, no question. Sorry about my video. I told you that it's in it's not really in a good position. It should be like this, but I think it's fine. Yeah. That is not fine for me. Anyway, any question? No? So there might be two reasons that you don't have any question. Reason number one, you're very genius. I mean, you're super genius. You understood everything. So no question. Very good. Second reason is you don't understand anything. So whenever you don't understand anything, you don't have any question. There is no overlapping, right? Like Mr. Akash was asking, overlapping. There is no overlapping. Either you have understood or you have don't understood. And that is the reason that every time I follow, whenever you don't have any question. I guess it is the first reason. All of you.
Sir, actually, we are researching, sir.
You are researching where?
From the book, and if anything happens, sir, from Google, sir. Actually, I have some question that I noted, sir. I want to discuss you in the next class.
It seems like only you, Mr. Akash. How about the other 35 students? How about the other 35 students? We are here 36, including me, 37. How about the other 36, 35?
So it's I cannot say that I totally understand the thing, but I think I need to reminisce on that, or I'm not sure which position I should ask the question. I need some time or elaboration to really understand the concept. That's why I'm just keeping short and trying to hear what more explanation you're going to say.
Okay. If you understand the fact, then it is all right. But if you want to know more, or if you want to be much more clearer view, or then you have to read by yourself actually. But it's just listening, because I think some of the topics are completely new to you, right? Many of the topics.
Most of them.
Okay, most of them. So whenever you have a new topic, if you just listen to me like 5 minutes, 10 minutes of each topic, absolutely not possible that you have understood everything. I told you, during the university life, you just have an idea that what you are going to study. Don't expect that you have understood everything during the class, right? But at least whenever you're trying to think, you might have some confusion, you might have some doubts, or you might have a different opinion. So that's when, again, asking that, do you have any questions? Whenever I'm asking that, do you have any question? That means I'm trying to find out that do you have any confusion, or do you have any doubt? Do you have any other opinion? Or that's what I mean. I actually don't expect that you have understood everything. At least if you understand, as Mr. Momin Rahman said, at least if you understand the fact that what we are discussing, then it is fine. That's what I want. But please, after the class, maybe tonight, maybe tomorrow, or maybe whenever you have time, please read or please study the topic I have discussed during the class. For example, I have just discussed about clock cycle. Now it is very easy to you that, okay, I know what's the clock cycle, very good. But to know more and to make this knowledge as a permanent knowledge, you have to read. You have to study about it. In the book, it is clearly written about the sister clock. Very nice description. The slides is not given that much information. You can go to the internet. You can go to the other sources to know about this sister clock. Remember, this is a very common question. One of my favorite about like this execution cycle and the system clock. And the last semester, last year I did one thing. I didn't discuss this topic, system clock. I give them home task about the system clock, and they learn by themselves. I will also, this semester, I will also do one thing, that one of the topic I will not discuss at all in this lecture. I will give you the self-study of only one topic. So it will be your task that entirely you have to study on that topic. I will not discuss anything, but of course it will be included into the syllabus. Okay, I will tell you, maybe I'm not sure about which one, but I'll tell you which one. But at least one topic. Why I'm doing this? Because it will give you a chance to self-study without having any help from my side. And it should have this habit that without having any help from anyone, how we can educate yourself. Very, 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 very important skill. I told you, you're not in a school or college level, right? That your teacher, your faculty, your parents teach you every single bit. In the university, you should do it by completely yourself. Okay, whenever I say yourself, it's not necessarily only you. Groups, you can discuss with your expert on it, but entirely up to you. It should be like our new. How can I explain? Number base code. All right. So why I'm saying this, because some of the instruction in the assembly language, they use only two variable or two number or two address to do a task. For example, if you want to add two numbers, you just use two numbers. You add first number with the second number and then store the result into the first number. That is one way. If you're using three variables or three address or three address machine, you are adding first number with the second number and store it into the third number. That's the three address machine. Most of the time, most of the processor we use currently, they are using either two address machine or three address machine. These types of processor, many of the time, many of the model, they use two address machine. And on the other hand, these types of processor, for example, our mobile phone processor, our other processor, our tablet, my tablet, this one. So they are using RISC types of processor where they use three address machine. That means whenever they do any task, they're using three address of the memory. They use two address for the two variables and they store the result into the third one. That's why it's called three address machine. Let us see some example. Look at this. This is three address machine. Okay, by looking at this, you don't understand anything. Let me explain. You can see there's an equation, right? Can you see the equation? A equal to B plus C multiplied D minus E plus F plus A, right? This is a normal, very simple arithmetic equation, right? We are going to execute this arithmetic operation by using three address machine. Do you understand? We are going to.
Can you just, I I mean, elaborate a little? I mean, I'm confused.
Okay, let me give this example. I think it will be all right. So look at the equation, arithmetic equation. Can you see the arithmetic equation? So we are going to perform. We are going to perform this arithmetic equation by using 3 address machine. Next time, we are going to perform the same arithmetic equation by 2 address machine. All right. We will perform the same arithmetic equation by load and store architecture. That is a different types of processor. Although we have 2 other types of microprocessor, 1 address machine, 0 address machine. We don't have any example here because the book Oh no. Okay. Can you hear me now?
Yes, sir.
You know
Yes,
the
sir.
problem.
Yes, sir.
The problem of campus is like on and off. The electricity gets coming again and going off again. It's a common problem. Anyway, that's why I'm disconnected several times. All right. So what we are discussing?
To address
Arithmetic equations.
three-
Yes, the arithmetic equation. Okay, let me share the screen again. Oh, difficult. Where is it? Screen. Start now. Can you see my screen?
Yes, sir.
All right. Is it my video is on?
Yes, sir.
Why there are 4 students are waiting? They don't have any profile picture, so they are not allowed to come. All right. Let them wait.
Actually, sir, I have some problem with the device, sir. I mean, I'm logged in with mobiles, and that's why I was trying to get into the classroom again with the PC, sir.
Then now it is fine, right? If it is
Yes,
fine,
sir.
if it-
It's fine.
now it is fine. So it's all right. Don't worry.
Yes, sir.
All right. Whatever we are discussing about the arithmetic operation, like 3 address machine. Please remind me if I exist the time because we have. Okay. So we have two other types of address: 1 address machine and 0 address machine. In the book, they don't give us any example. That's why I have not included any example. So I will explain how we can do that. But in these 2 cases, we don't have any specific example. I will show you how we can do that. Although, right? We don't have that much time today. Let me just do first of all one thing: 3 address machine. Let us do 3 address machine today. So in 3 address machine, according to the name, we are going to use 3 addresses or 3 locations of the memory to do each single task. Let me tell you again. We are going to use 3 memory addresses to do each of the tasks. Okay? For example, if we want to do a multiplication, look, how did you do it? MULT, multiplication, TCD, that means we are going to multiply C with D, and the result will be stored into the T location. Okay? Each of the capital letter, you can see these are the memory location. Right? Fine? So let us convert. Let us do this arithmetic equation by using 3 address machine. So whenever you look at it, I think you know it's a very basic that whenever we have plus, minus, and multiplications. Obviously, according to the arithmetic law that we have to do the multiplication first, right? Common, right? So we have to do multiplication first. So let us do multiplication first, and then we will do the other task. So let us start with the multiplication. We assume that we have one extra space or one extra memory location, which is called T. You can write anything else, no problem, it's just T. So we use T as a memory location, extra memory location, T, comma, C, comma, D. That means we are multiplying the value of C with the value of D, and then the result will be stored into the T. And the code is until this. After this, this is actually a, this is not a code, by the way, on the right side, after the semicolon. These are all comments. So don't worry about this portion, right? The assembly language code is on the left side of the semicolon. Okay? These are the comments. So in this comment section, you can see that T equal to C multiplied by D. Fine. Now T contains the multiplication of C and D. Now what you need to do? We have a B. So let us, because B is also plus and T is also plus, so we can do addition. So add T, comma, T, comma, B. That means we are adding the value of T, which is C multiplied by D, with B, and then store the answer into T again. Do you understand?
Yes, sir.
Now the value of T, same value, same location. Now the value is updated. Now the value of T is equal to B plus C multiplied by D. All right. Now this portion has been done. Now we have minus E plus F plus E. So now we need to subtract. So subtract this whole value with this value minus E. So let's do it. Sub S U B sub again T minus T minus comma E. That means T minus E. That's what it means. Sub. There is a misconception, and there is a common mistake in the last year. Most of the time, you did mistake here in this portion, in the subtract portion. Remember, we are doing subtracting from T, right? From T. We are not subtracting the E. We are subtracting from T, right? That's why T, comma E. That means T minus E. Many of you make a mistake here. They write TET. It's not TET. Then it will be opposite result. All right, so don't do this mistake. This is a very common mistake. So subtract, we have done the subtract TTE. That means we are subtracting the E from T, and we are storing the result into the T again after doing the subtraction. Now the value of T is this. Now it is very easy. We have plus F and plus A. So we do two addition. The last one you can see. Remember, we have to store all the information into A. There is a little bit problem. Look, we need to store the total result of A at the end of it, because the A itself has a value, right? Look, A itself has a value. So we have to do all the thing, use the A, and then we can store it into the A. If you don't do it, if you previously use the A, what will happen? The value of the A will change, right? It will be a wrong result. So we have to use the A at the end, so that the value of A initially it has at the end of that arithmetic equation, that's so that it will not change. All right, that's why, look at the last one. Add A, comma A, T. That means we are storing the value, we are adding the value of the T. That means the total one is the T plus A, and then storing into the A again instead of T, because we need to store the value into the A, not T. T is just temporary location, that's why we have T. Fine. Do you understand? It will take time.
Why, sir, it is A, and then T? Why not AT, then A?
Very good. It is also possible. Correct. Correct. You are correct. It is also possible because it is a plus, right? So you can do A plus B and B plus A, same thing, right?
Yes, sir.
C multiplied by D and D multiplied by C, same thing. But T minus E or E minus T, not same thing, right? So for the multiplication and the addition, these two you can do other way, no problem. But for the division and for the subtraction, you cannot change the position of the variable. Otherwise, you will have a different value. Okay? You spot it correct. It can be ATA. That is also correct.
Yes, sir. Thank you, sir.
Good. Any other question? If you understand this 3-address machine, trust me, you can do the 2-address machine by yourself. You can also do the load and store architecture by yourself as well. But you have to understand this one very well. Other two are the same thing, similar thing. Instead of having 3 variables or 3-address machine, you're just using 2 address. That's the difference. Other than that, everything is same.
Sir,
You just need to, yes.
sir, will you explain it again? What's
Again,
yes, sir.
okay,
It will be good.
okay.
Thank you, sir.
Let us start again. So this is our arithmetic equation. We can see there is a little bit problem with this equation, which is we have A 2 times. We are storing all the activities of this, and we need to store it into the A. But the problem is A is already there into the equation. So we cannot use the variable A in the beginning of our execution. We have to do it at the end of our execution steps, because if you do it in the beginning, you will change the original value of A. Let's assume that the value of A is 1. Right, the value of A is 1. If you store the value, if you store all the information like C multiplied by D, you store it into the A, then what will happen? The value of A will actually replace the value of C multiplied by D, right?
Yes, sir.
So we cannot do that. We cannot do that. We will do it at the end. So that's why we use one temporary location. In this case, they name it as T location. Obviously, these are memory location. All right, so we have used a temporary location T.
Sir, instead of, can we take any other letter?
Of course, you can write like my name, like R as well. Or you can start with your name, no problem. This is just, okay, these are just example, all right? These are just example. We are not writing on a very specific system, right? If you're writing in a very specific system, then you have to think about the exact memory location of the system, because we are just writing as an example, so you can write anything, no problem. Your name, my name, any letter, anything, okay? We use T because it's a temporary location, that's why. No other reason. Fine? Okay, so we are using a T. We are using a temporary location T. In that T, we know that we need to start with the multiplication. That is the rule. So we start with the multiplication C multiplied by D. So in the temporary location T, we are storing the multiplication of C and D. That's why we write MULT T, C, D. The first one, remember, the first one is always you are storing the data whenever using the 3-address or 2-address machine. The first one, you always store the data of the action. We are doing multiplication, so these two, the other two, will do the multiplication and store it into this location, always. Right? That's why the value of C and D will be stored into the T location. Fine. After that, now the value of T is now C multiplied by D. Now we need to do the next step. Next step is we have a positive B. So let's do it in addition. So T, comma, the value, the value of T. Now it is C multiplied by D, comma B. That means the new updated T is now B plus C multiplied by D.
Sir,
Yes.
can we write here E comma C comma D comma B.
What? Try again.
Practice.
Can we write T comma C comma D comma B?
Where? Which line?
Sorry, second line.
So you want to, okay, I understand. Yes, I understand. That is, instead of doing the addition in the second line, you want to do the subtraction, right?
Yes, sir.
Of course, possible. Because the plus and the minus, they are in the same preference. I think you know that. The division and multiplication in the same preference. Plus and minus, they also have the same preference. So you can do the same thing, no problem. So after doing the multiplication, all of them has the same preference. So instead of doing the addition with B, you can also do the subtraction from E. In that case, you can write the second line in that way, that sub T, comma, T, comma, E.
Okay.
In that case, your updated T will be C multiplied by D minus E, right?
Yes, sir.
That is also fine. Okay. So same way, you can write the third line if you don't do it that way. So we need to do the plus first, and then we do the minus, and then we do the plus again with the F, and then we do the last one. The tricky one is the last one, because you can see that we are not storing. Look at the last line. We are not storing the result into the T in the last line, because it is not asking to store into the T. It is asking just to the store in A. That's why we write the last line in that way, at A, comma, T. And also you can write A, comma, T, comma, A, same. To
Yes,
store.
sir, totally understand, sir.
So that we can store the result into the A. That is our ultimate target. Fine?
Yes, sir. Now it's clear.
Yes, sir, clear, sir.
Okay. Any more questions?
Yes, sir.
Thank you for asking me the question. Let me give you the attendance. Now the problem is, how can I give you the attendance? Okay. 1 minute. Difficult. Please wait. I'm almost there. You are section, which one? B, right?
C.
Oh, C. All right. Sorry, C. Okay. All right. So I found you. So CSC 197 section C. Please respond. Shakil Ahmed. Aminur Rahman.
Present, sir.
Saidul Islam. Moinul Islam.
Yes, sir.
Himen Shaukat. Shahriar Haq. Kadimul Haq Roni. Mukit Hassan.
Yes, sir.
Said Mukitul Islam.
Yes, sir.
Shabujur Rahman.
Yes, sir.
Ikon Kumar Das.
Present, sir.
Amit Hassan. Rubel Babu.
Yes, sir.
Rizwan Ahmed.
Present, sir.
Jannati Naim.
Yes, sir.
Imtiaz Tasnim.
Yes, sir.
Shahida Ahmed.
Sir.
Sadia Akhtar.
Yes, sir.
Afia Siddiqa.
Yes, sir.
Rahul Debnath.
Yes, sir.
Abdul Sabur.
Yes, sir.
All right.
Present, sir.
Ruhanul Kabir.
Yes, sir.
Rubayat Alam.
Yes, sir.
Samuel Rudro.
Yes, sir. Yes, sir.
Lamia Akhtar. Okay. Lamia
Yes, sir.
Akhtar. Fine. So my